Hi everyone, now let's get started about mutable and immutable objects in Python. So when we say a object is mutable in Python, that means the internal state of that object can be changed. And what is this about internal state? That part we'll understand with proper visualization and few code example and what's their impact in our code. So we will see all of these things in this video. And when we say a object is immutable, that means the internal state of that object cannot be changed. So, and these are the few examples of mutable objects, and these are the few examples of immutable objects. Now let's understand them with a code. So here I have taken a list object which contains two items 1 and 2, and here we have in this code, if you look at carefully, there are two variables li and new li, and both of these variables in this form are referring to this particular list object. So let's see this thing with a visualization that will give you a better clarity. So this is the scenario right now we have. So we have this list object which contains two items 1 and 2, and these two variables li and new li are referring to this particular list object, and this memory address is just a hypothetical one. So and this is their real memory address. As with this id function, when we apply on any variable, it returns the memory address of any object, and you can see as both of these variables li and new li are referring to the same object, so that's the reason we are getting here the same memory addresses. So the way we have mutable and immutable objects, same way few operations are mutable and few operations are immutable. So mutable operations means when we apply these operations on a mutable object, so in that case internal states of that object gets changed. Whereas even if we apply this mutable operation on an immutable object, internal state will not be changed, as internal state of a immutable object cannot be changed. And immutable object operations means these operations, even if you will apply on a mutable object, their internal state will not change. So we will see this part with a code example and visualization too. So now let's see. So right now we have this list, and now we are adding in this list a3. So and here we are using a mutable operation. So when we apply a mutable operation on a mutable object, in that case we changes the internal state of that object, right? So if you look at now, we have added 3 in this list, so that's the reason, as there were two objects 1 and 2. So now in the return we have got 3 objects now with this li, and here we can change the internal state of this, or we can add any element in any list with a mutable operation, with this plus equal to, with this append, with this extend. These are the like major methods, and doing this thing plus equal to and doing extend is almost like identical thing. Doing append also does the same thing, but only with a different syntax. So now let's see what has happened over here when we added this 3 in this list with a visualization internally. So when we ran this operation, so do you see we have added a new item in this list. But now if you look at carefully, our original object remains same. We have changed its internal state by adding 3. So memory address remains same. Li and new li are still referring to the same object. So if you look at now, new li value has changed because it was referring to the same object as which was referring by li2, and when we change the internal state of this object by using the reference of this li variable, so result will be reflected in this new li2 because it was also referring to the same object. So let's see the impacts. If you'll see, now the value of new li has also changed. But now if you will see the memory addresses of li and new li again in the code, you will find out they are still referring to the same original object. There is no change in both of these memory addresses, neither here nor here. Now let's do the same thing on a tuple. And tuple is a immutable object, and here we are using a mutable operation on a tuple. Over here we will do that. So for now, right now the situation is that we have this tuple object which contains three items 1 2 3, and two variables tu and new tu are referring to this particular tuple object. So if you look at in the code, so this is the scenario right now we are having. So we are having this particular tuple object, and two variables new tu and tu are referring to this particular tuple object. Now we have ran this plus equal to operation on this tuple object. That means we are adding two items in this tuple object. So now let's see what will happen with the visualization when we run this particular operation on a tuple object. So in that case, what will happen when we run this operation, when we add this 4 and 5, a new temporary object will be created. And just look at right now this tu is referring to this particular object. And now when this operation will get completed, then tu will change its reference from the old object to this new temporary object which was created. So now new tu is still referring to the old object, whereas tu has changed its reference. So now let's verify this thing with our code. So now when we run this operation, if you look at the new tu value is still the same, and the id for this tu is referring, if you look at now, it is referring to the different object, as both of these memory addresses are different now. But the new tu is still referring to the old object, and value of this new tu, if you look at so let me do one thing. Yeah, if you look at over here, we have verified that the value of new tu is still referring to the same object, and the value is still new tu value is 1 2 3, and tu value has changed to 1 2 3 4 5 after this object. So that's what has happened. So tu value has become 1 2 3 4 5, and new tu is still referring to the same original object. So new tu value is still 1 2 3. So I hope this things gives you a idea what happened when we apply a operation on a immutable object, despite that is a mutable operation. So internal state of immutable operation never gets changed, they just change their references. So it's like that they create a new object and they change their references. And as per the Python memory management, if there is a suppose this new tu was on there in the picture, so whenever a object is having without any reference, so that object will get garbage collected by a garbage collector module in Python. So now let me run the whole code again, so these memory address will be changed a bit. Yeah, so now we will see their impact, these mutable operation and these immutable operation impact in our code. So now let's say we have this R list. Or first let me create a one more list, and this list contains, so let me keep this thing as a list R list, and this R list contain, let's say, two elements 1 and 2, and we have one more list. So let's say we have this F list, and this list contain, let's say, 11 22, and again this I list also part of its item. So now let's run this F list. So right now we have this F list. So in this scenario, if we look at right now, when we have this scenario, this F list, and F list contains another reference to a variable which is referring to the other object. So right now scenario is this. So we have this object 1 and 2, and they are right now two references of this object. One reference does by this I list object, and other reference is this I list, because this I list is not an independent I list, but this I list is part of this list. So right now these two I list, this I list and this I list, are referring to this particular object. So if you will change either one of them, so we will change the internal state, as if we will do a mutable operation on a mutable object. So changes will be reflected both ways. Let's see this thing with the example. So if I'll change this R list, so and let's run a mutable operation. So the way we did over here. So let's do one thing. Let's add again. Let's say 3 over here in this R list. So or we could add like with this plus equal to, and as we could compare this thing with the tuple easily. So that's why I'm using this operator. Same thing you could do with append or extend. I think you can use a mutable operation. So now if you will see, the value of this R list has changed. But if you look at the value of this F list has also changed, because they both were referring to the same object and we have changed the internal state of this object. Now let's do the same thing on a tuple. So let's say we have this I tuple, and this tuple contains, let's say, it's the same element, let's say 1 2, and let's say we have one more, let's say ftupl, f tuple. And when we have this particular f tuple, and that's in the same element, let's say I tuple. So right now the scenario is the same. We have this tuple object and there are two variables, this I tuple, which is the independent I tuple, and I tuple, which is the part. So instead of this, let me make it again. Or we could have done on a list also, does make a change. So let's say new list. So it will remain same. It will not make any impact whether we use a list object or a tuple object if something is a part of this, because right now a mutable object is part of a mutable object, and in other case a mutable object was a part of a immutable object if that would have been a tuple. Now what I'll do, now when I have this I tuple, now I'll change this I tuple reference to a, let's add one more item, let's say 3. And now if we look at now the value of this I tuple, sorry, let me run this code and now it will accept, yeah, has changed to 1 to 3. But if you look at the value of this new list, will it change? Think about that. What happened to a immutable object? If you look at it, is still the same, because internal state of a immutable object cannot be changed. So what will happen in that case? The same thing what happened over here. So think about that you could compare in this way, that there were like two I tuple variables. One was a independent I tuple or another I tuple which was a part of our list. So and when we changed the reference, and they were referring to the same object, and when we change the independent I tuple, so it change their reference to the another object which was created temporarily, and then I tuple changed its reference, whereas the I tuple which was the part of a list was still referring to the same original object. So that was happened over here. So that's the reason this thing is pretty important to understand. So and this thing could create a lot of like issues if you don't have a clarity about these things. So now let's see if one more thing like which were pending, I think, over here, which we should have done before. But now let's do now that what happens when we run a mutable operation, that too on a mutable object. So right now we have, let's do on this new list object, and let's see the ID, add a few more cells on this new list object. So let's say new list. So we have this particular new list object, and what we are doing over here, now I'm adding one item in this new list, but I'm adding a item on this new list not with a mutable operation. So let's use this. Let's say new list plus 3, and this operation is a mutable operation. So that means here a variable change kind of a thing will take place, internal state will not be changed. So now what will happen? So now let's see the new list. If you'll see, we have added the 3, But if you look at the memory address of this new list, you'll find out it has changed, because this plus the is a this kind of operation is a immutable operation. Even if you do on immutable object, they don't change the internal state of your object. So I hope this video has given a basic idea about what's the meaning of the change of internal state and how do they impact in our code. Though there's much to learn on this internal state part and how do they impact on in when we use function and a lot of other places, but this video I hope gives you a real basic idea about these mutable and immutable objects, that what are they and what's the difference, and what's the difference between mutable operation and immutable operations. And furthermore, if you want to learn more, then please comment in the video that you want to see the more material about them. So I'll see that if I could add in one of some of my courses, then I'll let you know about those courses, or I'll add in some few more videos in the same playlist. So please comment. So as per your convenience, I'll try to add on new material. So thanks a lot, guys, for watching this video, and please don't forget to subscribe this channel. That will be huge support for me. Thanks a lot. Bye bye.